So question 4, momentum is a vector quantity. How's the vector quantity different from the scalar? Well, yes, the student has said the vector correctly does have direction and magnitude. The scalar has magnitude though, or size. That would do. Displacement is a good example of a vector quantity. Velocity, acceleration might be alternatives. Give a definition of momentum. Right. When they ask for definitions in this particular exam paper, often what they're looking for is the equation. So writing momentum equals mass times velocity. It has to be velocity, not speed. We'll get the mark. You can't say the unstoppability. I know I used that in class, but in the exam paper, if they say give the definition, they mean write out the word form of the equation. The unit of momentum there, the kilogram meter per second, is correct. Okay, next question, or next part of this question. We've got a golf club. It's in contact with the ball for 1.8 milliseconds and it's exerting a force. There we go. We need to calculate the velocity of the golf ball. Right, so I've done this in 2 stages. So to begin with, it's given me a force and I've calculated the acceleration. You can see I've done that by using Newton's second law, F equals ma, rearranged it, put the numbers in. And that gives me, in fact, I didn't write the acceleration down because it was very, very large. You can see that I've just moved it over to there. Then I've used the equation for the acceleration, which is change in velocity. That sign there is delta, which just means change in velocity. You could equally have used a equals v minus u, change in velocity over time, same thing. So change in velocity by the time you've rearranged it is acceleration times by the time. That's the acceleration from there. And the contact time is, now look, this milli comes in again, 1.8 divided by 1,000. Okay, it has to be 1,000. I've used standard form and often that's a nice way of doing it. 1.8 times 10 to the minus 3 gives me a velocity of 60 meters per second.